Good day, students. This video is about chapter 3E of the textbook, completing the square and also the turning points here. So here I'm going to show you how we're going to transpose from general quadratic trinomials into a turning point form using the concept of completing a square. So firstly, recall the perfect square formula here. You have the x squared plus 2ax plus a squared, that will equals to x plus a, everything squared, okay? So the minus situation, it can be written as plus a negative a, okay? Then we're going to quickly go through this example of completing squares, okay? So here I give you a quadratic trinomial expression, which is a mnemonic, okay? And here I have listed a few of the steps that I have summarized, okay? Feel free if you want to post the videos and take a look about those steps. So step one, it says you've got to take in the leading coefficient as a common factor for the x squared terms as well as the x terms. So what I do here is I'm taking the 2 out of not just the x squared term, but these two terms together. Okay, so I'm going to take the 2 out, which means the first, the leading coefficient, the leading terms that only have a mnemonic x squared left. For the second term, which is the minus 3x, because I've been taken 2 out of this 3, and then you have a remaining factor being 3 over 2. Okay, so this is a bit of the algebra trick here. Okay, although we know that the 3 is not divisible by 2, but what we can do is we can consider this as the fraction, which is 3 over 2. Okay, now this is the first step. Now also notice here, I'm not doing anything with the constant, so I'll just leave the constant outside of the bracket. Just don't forget to write this every single time, okay? And then we have the second step. Second step, which is the actual completing square bit, okay? So then you're going to add half of the coefficient of the x term in the bracket, and then you square it. You're going to subtract the same term that you have just been squared or just been added. So notice here, we have a 3 over 2 here, or you can say negative 3 over 2. We're going to half it. So then I'm just using half times whatever the coefficient in front of the x. And then I take a square. So this is the particular constant I have added in order to completing a square with the first two x terms here. Because I have added this term, in order to keep the size of the expression the same, I have to subtract the exact same term here. Okay. The next step is to take in the subtracted term outside of the bracket by multiplying with the leading coefficient. Okay. So I want only these 3's to be sit in the bracket. I don't want this one here. So what I can do is I can take this one outside of the bracket, but you can't just take it out. You have to multiply the factor 2 because the factor 2 has been taken out first. Therefore, I'm multiplying 2 here, as you can see, multiplying 2, and then with 3/4, since I have using half times the 3 over 2 here. Okay, now you can see the first 3 terms are forming a perfect square form. Then you can factorize the trinomials in the bracket to make a perfect square, and then you're going to simplify the constant. So firstly, let's rewrite these 3 terms into a simpler version, which is the perfect square form, x minus 3/4 squared, which x is the base for the first squares, and then it's a minus in the middle, so you have a minus there, and then 3/4 is the base of the constant term. So here you have a 3/4 there. And then we're going to simplify all these constant at the back. You have a negative 2 times 3/4 square give you 9 over 16 minus 1. Okay, so negative 2 times 9 over 16, you get negative 9 over 8. Minus 1, we can rewrite as 8 over 8. So now you have negative 17 over 8. Okay, so this is how we're completing a square. It's just a quick recap. Now, next one, this is the actual thing that I'm going to talk about here. From a quadratic general polynomial form, which is y equals to ax squared plus bx plus c, to the turning point form, y equals to a bracket x minus h squared plus k. And notice here, only the pronumeral a's are the same, okay? So only the pronumeral a's are the same. Basically, the same letter referred to the same quantity here, okay, to represent the same value. So we know that these two a's supposed to be the same. However, here you have h and k, here you have a b and c. They are not so obviously related. That's why I need to figure out what is h actually represented in terms of, you know, the a, b, and c, as well as how k is represented in terms of the a, b, and c's. All right, so we start with these general trinomials, non-monic trinomials, okay? Just like we trying to complete a square with the numerical example, I'm going to take the leading coefficient a outside of the first two x terms, okay? So specifically the x squared term and the x term. And then you have a monic situation here. You have x squared plus b over a. Since I don't have any factor a in the b, so you have to divide by a to write in the fraction form. Okay, notice c does not involve in this factorization, so c is outside of the bracket. Then I'm going to add half of the coefficient for the x term. So recall the x term is b over a. I'm going to times by half, and then I'm going to square it. I'm going to subtract the very term I have just added in order to keep the equation the same size. Notice here I also copied the c. Okay, so far I haven't done anything with the c, so we just leave it. Then we want these first three terms joined together in the bracket to make us a perfect square. I want to take this minus half b over a everything squared outside of the bracket. That's why I'm going to multiply a again, okay, on top of this. Don't forget there's a plus c. The next step is you write the perfect square form, which is x plus b over 2a, everything squared. And then you minus a times b squared over 4a squared, as you have simplified here, and plus c. So we already have the perfect square form here. And as for the constant, let's quickly try to combine them all together. And then in the end, you will get 4ac over 4a minus b squared over 4a. Okay, so since they are all in 4a in terms of 4a's, we can summarize them by put them all together as 4ac minus b squared everything over 4a. And I can rewrite x plus b over 2a in the bracket as x minus negative b over 2a, so that we can actually match with the actual turning point form. So you can see the turning point form, the a is the same as this a, and then you have x, which is the same, minus, which is the same. Okay, so here you have h, here you have a negative b over 2a. Therefore, we can say h is actually equal or equivalent to negative b over 2a. Okay, recall the a and b are the coefficient of the x squared term and the x term in your general quadratic polynomial form. And then we can see the term here, the k, it is referred to this thing here, okay, which is 4ac minus b squared over 4a. That is actually represented by k. So knowing this is not enough, we need to further find out the x-intercepts here, okay? So you can take a look. This is the x-intercept form in the turning point form. You have h plus or minus square root of negative k over a. You notice here I'm just substitute h that equals to negative b over 2a, substitute k that is equal to this thing here, over a. Okay, and then you can see that I have undergone some simplification, rearranging, and then you can see that I got b squared minus 4ac over 4a squared inside of the square root. If I rationalize it and combine with the two terms that have the common denominator of 2a, I finally get what is called the quadratic formula, negative b plus or minus square root of b squared minus 4ac, everything over 2a. So this is the quadratic formula, or helping us to find the x-intercept based on the polynomial form, which you can see that is derived from the turning point form. Alright, so next I would like to show you how to represent the 5 key features of a parabola based on the polynomial form. So you can say for y equals to ax squared plus bx plus c, since we know that the a is the same a with the turning point form, so a still controls the general shape. As for the axis of symmetry, we know that h is equal to negative b over 2a, so x is equal to negative b over 2a. So this whole thing here is represented by h, okay? As for the turning point, we already figured out the h and k, which is represented in terms of a and b and c. So we have the x coordinates, negative b over 2a, as the x coordinates of the turning point, and then we have the y coordinates of the turning point being 4ac minus b squared over 4a. With this general polynomial form, it is much easier to find the y-intercept, simply because the y-intercept is where you make all the term that contains x being 0, and the only term that is potentially non-zero is the constant. Okay, in general, that the constant will be equal to y. Okay, so here is going to be the y-intercept. Lastly, you have the x-intercept. In order to determine whether you have x-intercept, you're using the b squared minus 4ac, which is what we call as a discriminant, right? So you're using this to help you determine whether your parabola have x-intercept, have how many x-intercept. Okay. All right. If you have any questions, make sure you come and see me, or come to Maths and Numeracy support. Thank you for watching, guys. I'll see you in next video.